What is the total circuit resistance of this circuit? It's a very simple circuit. We just have two resistors in series with one another. So finding the total resistance of the circuit shouldn't be too tricky. All we have to do is add the resistors together. R total equals R1 plus R2, which will be 100 ohms plus 100 ohms, 200 ohms. Not too hard, right? Question 7. Find the current through each resistor and the voltage drop across each resistor. Now this is going to be a little harder. What we're going to do is find the current first. To find the current, we need the total resistance of the circuit and we need the voltage, both of which we have. So what's the total resistance of the circuit going to be? Well, as long as we can find it, we can find the current. So the total resistance is going to be 20 ohms plus 10 ohms plus 70 ohms, right? That's going to be the total resistance of all three resistors because they're in series with one another. The voltage, of course, is just 240 volts given to us in the question. So that will give us an answer of 2.4 amps. That is 240 divided by 100. Now, how do we find the voltage drop across each resistor? Well, using Ohm's law, we need to multiply the current, 2.4 amps, by the resistance. So the voltage drop across the first resistor, the 20 ohms, is going to be 2.4 times 20, which gives us 48 volts, right? So across here, we have 48 volts. If we like, we could say that the potential left over at this point is plus 192 volts. That is 240 minus the 48 volt drop across the 20 ohm resistor. What's the voltage drop across the second resistor going to be? Well, it'll be 2.4 times 10, which gives us 24 volts. So the voltage drop across here is 24. Finally, the last resistor has a resistance of 70 ohms, so the voltage drop across this one will be 168 volts. And we can see that if we add all of these together, we'll end up with the 240 volts that we start with. So, if we wanted, we could say that we start off at plus 240 volts. After the first resistor, we get to plus 192 volts, so that the potential difference between the two is 48. After the 192, we drop down to 168. So once again, the potential difference is 24 volts. Then 168 goes down to 0. This means that the total voltage drop across everything will be 240 volts, and the voltage drop across each resistor will be as shown. So every time we go across a resistor, the potential goes down. Question 8. Two resistors are connected to a power supply in series. Fair enough, we've been doing series circuits. The power supply produces a voltage of 10 volts. The current that runs through the circuit is 1 amp. If one resistor has a resistance of 7 ohms, find the resistance of the other. So what we have is a circuit that looks like this. Power source, two resistors, and a current through them of 1.0 amps. So the current will go in this direction. Now, how do we find the total resistance of the circuit? Well, we can use V equals IR, right? Ohm's law. Then we know the total resistance of the circuit. And if one of these has a resistance of 7 ohms, then we can use that to find the resistance of the other resistor, assuming we know that the total resistance is given by Ohm's law. The total resistance of the circuit will be the total voltage over the current, which is of course 10 volts over 1 amp, or 10 ohms. With me so far? Now we take this 10 ohms and we combine it with what we know about the first resistor. So this will be R1 plus R2, and R2 will be the total resistance minus R1 because of how the total resistance works, right? So substituting 10 for the total resistance that we worked out here, and 7 for the resistance of the first resistor given to us in the question, we can find that the second resistor has a resistance of 3 ohms. Question 9. A set of Christmas tree lights consists of 20 globes, each with 10 ohms of resistance, wired in series. If the lights are connected to a 240 volt supply, find the voltage drop across 3 consecutive globes. So how are we going to work this one out? Well, it might be best to find the voltage drop across each resistor and then perhaps multiply that by 3, right? So the total current through the circuit is given by the supply voltage over the total resistance. The total resistance is going to be 20 times 10, because we want to add each of these 10 ohm bulbs together. So 240 over 20 times 10, that is 240 over 200, gives us 1.2 amps through the entire circuit, right? Now the voltage drop across 3 consecutive resistors is going to be the current times the total resistance of those 3 globes, which will just be 10 ohms plus 10 ohms plus 10 ohms. 1.2 times 30 gives us a voltage drop of 36 volts. So that's our answer. Question 10. Mark the potential at points A, B, and C. So we can see that we start off at 20 volts and end up at plus 0 volts. So the potential difference, that is the voltage that the power supply provides, is 20 volts. So all of these 20 volts have got to drop across this circuit. The easiest way to figure this out might be to find the current. The current's going to be 20 volts over the total circuit resistance, which ends up being 100 ohms when we add all of these together. So that, of course, is 0.2 amps. So we'll take this 0.2 amps and multiply it by 20 ohms. That gives us a voltage drop of 4 volts. So the voltage between 20 volts and A is 4 volts, right? That means A has a voltage of plus 16 volts, right? Because that's the difference between the potential here and the potential here. All right, what about the potential between A and B? Well, if we have a 10 ohm resistor, then the difference between these two potentials must be, that's right, 2 volts, right? So if we have 16 for one and the other one is lower, then B must be plus 14 volts. What about the difference between plus 14 and C? Well, once again, voltage drop across this resistor is going to be current times resistance, and 0.2 times 40 gives us 8 volts, right? So C must be plus 6 volts. And to check our answer, we can look at the voltage drop across here, which will, as we can see from Ohm's law, equal 6 volts, which matches up exactly with what we see here. So this gives us the voltage across every different circuit component, which allows us to mark the potential at points A, B, and C. So that's the end of the questions. In this section, we've talked about resistors in series with one another. We've talked about the total resistance, or the effective resistance, of these resistors, and we've looked at how the voltage drops across series of resistors.